Hello friends, yes, in this third lecture of solution we will see the partially miscible liquid pairs. What is the effect of temperature on partially miscible liquid pairs? Depending on the mutual solubility, there are three types of partially miscible liquid pairs. From that, one is a liquid pair whose mutual solubility goes on increasing on increasing temperature. First type is mutual solubility increases on increasing temperature. Okay. From that we already seen phenol water system, phenol and water system. At room temperature or at low temperature, if we take phenol and water, there is a formation of two layers. One layer is a water in phenol, other layer is a phenol in water, and on increasing temperature both mutual solubility goes on increasing, and at certain temperature, that is 66.5 degrees Celsius temperature, these partially miscible liquids becomes completely miscible, and above this temperature in any proportion phenol and water are completely miscible with each other. That's why it is called as the upper CST. CST, consolidate solution temperature or critical solution temperature. The temperature above which partially miscible liquid pairs becomes completely miscible, that is phenol water. This is the first type of partially miscible liquid pair. Second type of partially miscible liquid pair is the type where mutual solubility decreases on increase in temperature. Mutual solubility decreases on increase in temperature. And best example of this system is a triethylamine water system. Triethylamine water system. TEA water system. Now what happens in case of triethylamine and water? Below 291 Kelvin means 18.5 degrees Celsius. Below 291.5 Kelvin or 18.5 degrees Celsius, this triethylamine and water are completely miscible with each other in any proportion. Means if we try to plot the graph of temperature against composition, initially here if we consider 0% triethylamine, percentage goes on increasing, here 100%. If we consider any composition below certain temperature, that is 18.5 degrees Celsius, these triethylamine and water are completely miscible with each other. There is no separation of two layers. But as we go on increasing temperature, what happens? At 18.5 degrees Celsius temperature, there is a separation of two layers and we will get such a parabola. Below this temperature, these triethylamine and water are completely miscible, and above this temperature they becomes partially miscible. Now if we consider this diagram here, okay, below this 18.5, see, there are two layers. The diagram should be as like this, and here should be 18.5. Okay, Now if we consider any point outside this parabola, suppose consider a point below 18.5, there is no need of explanation. Below 18.5, any composition as a homogeneous solution. Two liquids are completely miscible with each other in this region. Okay, but above this temperature, suppose we consider any point X, say this point X. Okay, not this point, I will consider this point, say X. What that point or that composition states here, suppose this is the composition denoted by X. Composition X at this particular temperature, suppose Tx, it is a homogeneous solution. Homogeneous solution of triethylamine in water. Here water is 100%. Here water is 100%. This is the unsaturated solution of triethylamine in water. Now if we decrease temperature, just there is a decrease in temperature. But if we increase temperature, at certain point it becomes saturated solution, and above this temperature there is a formation of two layers. Similarly, if we take any point to this side, suppose point Y, what this point Y indicates? It is the unsaturated solution of water in triethylamine, because here triethylamine is 100%. Water percentage is low, means here water percent may be 20%. 20% water and 80% triethylamine is denoted. Suppose this is by Y, then it is an unsaturated solution of water in triethylamine. If we add water here, what happens? At this point, two layers separates. If we decrease temperature, temperature just goes on decreasing. It is a homogeneous solution. If we increase temperature, at certain temperature, say Ty, two layers get separated. Or this is the actually saturated solution of water in triethylamine. Any point inside this parabola, any point inside the parabola, suppose a point say P, it consists of two layers. One layer is a solution of water in triethylamine, other is a triethylamine in water. Okay, two solutions are there. We call them as a conjugate solution, and the point composition of these two solutions is given by point on this parabola, say A, say B. Two solutions are there. One solution is a saturated solution of this composition, saturated solution of triethylamine in water, and other solution is a saturated solution of water in triethylamine. Okay, got it? And this is a lower CST. As we go on increasing temperature, they becomes more and more immiscible. This is about second type of system, that is called as a minimum solution temperature system. This temperature is called as a minimum CST. How will you define this minimum CST? It is the temperature below which, two liquids are completely miscible, and above which two liquid becomes partially miscible. Okay, that is called as the CST. Since it is a lower temperature, it is called as the minimum CST. Below this, above this temperature, they are becomes partially miscible, and below this temperature they are completely miscible. That's why it is also known as a minimum CST type of liquid mixtures, because mutual solubility goes on, yes, decreasing on increasing temperature. Okay, got it? Okay. Now we will see the third type of liquid pairs.